Okay, so how you will define coherence? You can say that coherence refers to the correlation between two or more signals in the frequency domain. It measures how well the signals are related to each other in terms of phase and amplitude. Like coherence analysis helps us reveal functional connectivity between different regions like brain or muscles across different frequency bands. And what are the types of coherence? So first type of coherence is cortical coherence. It shows the coherence or synchrony between the two cortical regions, two brain regions, how well functionally connected with each other. For example, coherence between the supplementary motor areas and primary motor areas during the preparation and execution of the voluntary movement. Second one is cortico-muscular coherence. It measures the coherence between brain cortical activity. We can measure the brain cortical activity with the help of EEG, MEG, or using microelectrode, which measures local field potential, and the electromyography EMG. Means we generally want to see how well brain region and muscular regions are correlated, means well connected with each other. Means if we are trying to grasp something, so there must be some muscular activity and there must be some cortical activity. You want to measure the coherence between these two. And the third one is intermuscular coherence, means coherence between two muscular regions. How you will find the coherence mathematically? So to find them mathematically, you will use this formula where C of xy f measures the coherence value of two signals at frequency f, whereas pxy of f gives our the cross spectrum at frequency f for signals x and y, and pxx of f gives auto spectrum for signal x, and where pyy of f is outer spectrum for the signal y. So when you will get the value of Cxy of f, if it's 1, it means there is a complete linear correlation between those two signals. While if its value is 0, which indicates there is no linear correlation. So how you will find the Pxy of f? So you can use this formula to find the Pxy of f. You can go through in details if you are unfamiliar with these terms. So where here R X Y of M represent the cross spectrum sequence signals of the time series for X and Y for the first M sampling points. So you can implement this formula using MATLAB codes. There you will find different commands for these terms. It's easy to find, not hard as it seems in the formula. Okay, so next let's talk some experimental values what paper is showing. Let's talk about this paper, Pichori et al. 2023. They measured the coherence. They measured the cortico-muscular coherence (CMC). So the first figure you can see in A, here it's the coherence between left hand while extension of the fingers. Subject were doing extension of the fingers and using left hand, and you can see a very good coherence between cortical and muscular region CMC. And then the figure B, you can see while it's grasping, same left hand grasping, this time grasping, you see the coherence. And the third one is like right hand extension, and the fourth one section D, here you can see is uh, right hands while grasping. Okay, let's talk about the grand average corticomuscular coherence pattern in stroke patients. Here you can see in section A, subjects were not able to, they had like, they were stroke patient, not properly functioning hands, so they can perform motor tasks. The first task here you can see in A is unaffected hand doing extension. Subjects were doing extension with unaffected hands. So you can see coherence, but not that much great. It's not that great. In the second case scenario, you can see subject were doing grasping with unaffected hands. Still not good, not that good coherence. And the third case, there is very minimal, approx to no coherence in affected hands, and then while doing extension, and you can see unaffected hand while doing you can see affected hand while doing grasping, there is low coherence. What do you mean by doing extension and grasping with affected hand? It's like trying to do, means the hands were affected, obviously they were not able to perform tasks as normal subjects, but it means they are trying to do. In that case, it is a measurement of the coherence. Okay, let's move on. This is the summary from various papers based on the cortico-muscular coherence. You can see the patterns here. If you go through these slides, you will see there's the proper patterns, which indicates that in almost all the cases in healthy subjects there is very good coherence between cortical areas and muscular areas. But in unhealthy, I mean stroke patient, affected hands, in those cases, in those scenarios, there the coherence drastically decreased. You can go through these papers for the reference purposes to know more about coherence, especially corticomuscular coherence. Thank you so much.